Welcome back to the shop and to the channel. Well, this week's video is it feels a little disconnected to me because things didn't go quite the way that I had planned, but I am back to working here on the DIY DRO project. There have been some changes to the interface a little bit, and I want to work on connecting a servo motor to the DRO board. This bottom row on the DRO is for a servo motor controller, and if I enable it and have a motor connected to it, I can use it for, say, driving a dividing head, or I could use it for driving some kind of a tool holder. Really kind of the sky's the limit. It's really up to me. And when it's in indexing mode, I can do what you just saw there. I can move it, degrees or divisions. But I can also link axes together. So in this case, I can link the x-axis with the servo. It's currently set up with a gear ratio or a ratio of 360 to 1, which means if I move the x-axis 1 inch, it should rotate the servo by 360 degrees here. You can't see me off camera, but I am turning the crank handle on the table axis, and as I approach 1 inch, you can see there the servo went from 0 and then from 360 all the way back to 0. Now I can change that. So in this case here, we'll change it to 720 degrees, which means I'll go ahead and zero the servo, we'll zero the DRO. Now, if I move the x-axis 500 thousandths, you'll see that same 360 degree rotation. Or if I move it an inch, it will revolve the servo motor 720 degrees, or at least that's, what the expectation is. There's a lot more setup that goes into making this work, but the first thing I need to do is to get a servo driver connected to the rotary controller board. This is the servo driver and motor that I chose. I will leave a link down in the description. I got this off of Amazon. It's a 750 watt motor capable of, I think it's 3,000 RPM is the rated speed. It was pretty cheap. It was only about 150 bucks. And as far as servo goes, I guess that's pretty inexpensive. It came with all these cables, and it looks like it's pretty straightforward to set up. This larger plug here is for the primary power. It not only feeds power to the servo itself through this cable, but it's also where you connect line power. Now, this particular servo is running off of 220 volts AC, single phase. Before I go and connect everything up permanently inside the DRO cabinet, I do want to test this thing out. So I'm going to, I guess you would call this bench testing it, as much as it can be bench tested. I'm still going to use the DRO to test things, but I'm just going to leave the cables kind of hanging here. This thing came with this little white clip that presses on a spring that makes it a little bit easier to connect these wires. It's a, versus, a screw or a solder terminal. There are actually two cables that run to the servo motor itself from the driver. One is this power cable, and there's another one which is the signal cable. That one is pre-made. It's already got a plug on either end, so I don't have to do anything with it. I have this power and ground cable hooked up here. This is temporary. I'm using one of these Wago style connectors all this is going to get changed when I do the final install. However, to connect the servo driver to the rotary controller PCB, I do need this D-sub-25 connector. Now, the manual does have pinouts for it, but unfortunately, the manual that ships with the servo driver is actually incomplete. There's 2 pins that are not listed, and this was my original pinout, and this is wrong. I got some of this information from Stefano. He's the engineer behind the DR DRO. And I figured I'd use some Cat6 cable, twisted pair. Might be a little bit better for signal integrity between the rotary controller and the servo driver. So I stripped off some of the insulation. There's this plastic piece that runs down the center of it to make it more rigid. Cut that out of the way. I ended up, stripping back some of the insulation on several of the wires. I didn't need to use them all. And then I tinned them with some solder and then went through the arduous task of soldering these things to the D-sub-25, which maybe it's because I'm getting a little bit older, but it wasn't a whole lot of fun. I did end up using some magnifying visor in order to make this a little bit easier, but I think I kind of made a mess of this. Even though it looked nice when it was all together and attached to the servo driver, it was wrong. Not only did I not wire this up correctly, but I ended up struggling with this for quite a while. I could not get this to work. Even when I thought I had it right, I was still running into problems where the servo, it just wasn't reacting when I was expecting it to. Lucky for me, Stefano has set up a Discord server for DR DRO and his company, Provito. And so I jumped on the Discord and I was working through some problems with him. We even did a call through Discord and was able to use my camera on the phone to show him what I was doing. He did point out a couple of issues where I had gotten something wrong, but I was still struggling. It still wasn't working, and I couldn't quite figure it out. Lucky for me, one of the other participants on the Discord is a gentleman by the name of Luke, and he happened to be using the exact same servo that I was, and he was able to get it to work. And so I was able to share with him some photographs of the wiring and also my configuration in DR DRO, and he pointed out where I was doing some things wrong. Not only did Luke give me an alternative for the pinouts, or as far as the wiring between the board and the D-sub-25 that connects to the driver, he suggested I use something like this breakout board to make it a little bit easier to try some things if things aren't going quite right. And this is the correct wiring that I have here up on the screen. However, that didn't solve all of the problems. And I'll get to that in just a minute. One thing I ended up doing off camera is I built this hinge for the servo driver, and it mounts to the inside of the enclosure for the Kearney and Trekker. And once these cables are gone, it just gives me an easy way that I can keep it inside the cabinet. Everything's protected. But when I need to, I can pull it out and open up this cover, which is how you program the servo driver. And this is where I needed to make some changes in order to get this to work. One of the changes I needed to make, well, there's 3 changes, and I've got them listed up here on the screen. The first one there, function 52, I needed to change the enable state of the motor to be -1 versus 1. The rotary controller board expects to send a low value to the enable pin, and I needed to reverse that, which is what that function there does. There's also these other 2 values that are for setting the gear ratio, what's called the gear ratio internally. And this just makes the servo behave a little bit better. This is a tip that I got from Luke on the Discord server. I put a link to the Discord also in the description of this video. There's also some diagnostic modes like this one here in 14, which shows me the state of the enable pin, and you can see there on the left that enable is normally low, and I'm switching it to high, and that's why I had to flip over that number 52. So now with everything hooked up, the motor spins freely, but when I push on the R button, right, to enable the servo, it locks it up, it puts on the brake, and then when I disable it, it allows it to spin freely again. So everything should be working as expected. However, there's still some other settings that I needed to update. Number 1 definitely is this gearing ratio in the servo setup. Right now I've got it set up for 360 degrees will take 10,000 steps rather, to turn 360 degrees. I end up changing that later, but that was after I got some of that extra detail from Luke. So now when I have everything the way it is, when I click those index buttons, the servo moves, in this case 90 degrees at a time, because I have it set for 4 divisions. Now these gearing ratios are going to take some effort to try to figure out, and right now I still have a lot of figuring out to do, because I don't know what these final numbers are going to end up being for my situation. The servo is going to end up driving something probably through a couple of gears. That's going to have to be taken into account. It might be driving something that also has a gear ratio, like a dividing head has a 40-to-1 ratio. So all of that is going to take some effort and some math to figure out. But I think as the user interface for the DR DRO matures, I think it's going to be a little bit easier to try to figure out what those values are going to need to be. I remind you that all of this is open source, including the circuitry, the circuit diagrams, the printed circuit board designs, and the software that goes into the DR DRO. It's all open source and available on GitHub. And I'm actually making some contributions to the project myself. And if you're, a little bit adventurous and maybe know some Python programming, there's no reason why you can't help contribute to this as well. Another thing I want to accomplish here in this video is to tie up these cables. They can't come out of the door. I've got to figure out an alternative to plugging the servo driver into the servo motor itself. And what I came up with is another version of the same plug that I used to actually plug the DR DRO display into this cabinet. I've got 2 more. One I'll use for the signals and one I'll use for the power to the servo motor. I'll drill those holes and get that stuff mounted up off camera. I went ahead and drilled the holes for those two plugs, one for the data and one for the power to the servo. I also added this power switch, which kills power or turns on power to the servo driver. I don't want that thing on all the time if I'm not using it. Since each of those three plugs have different pinouts, I can't mix them up. They only go in one of them, and they're waterproof, so they shouldn't be affected by coolant or anything like that. I went ahead also and spent some time at least trying to neaten up things on the inside of the cabinet. I ended up sticking with the breakout box for now for that D-sub-25 connector at the top, but I think I'm going to eventually change that out to something a little bit lower profile. When I want to use the servo, I just need to plug in each of the two cables to the two plugs. I suppose I could have turned those into a single plug, but I didn't want to do that for whatever reason. And then just turn on the power switch. This turns on the power to the servo driver. Having the servo driver on the hinge is not just beneficial from a programming perspective, but it also displays the RPM of the servo as it's turning. I also wanted to share some of the updates that Stefano and myself and others have been making to the DR DRO project. One of which is we now have the ability to connect it to Wi-Fi. It can scan your wireless networks, and you can connect to any wireless network, enter in the Wi-Fi password, and you'll be connected to the internet. Well, the advantage that this now gives us is the ability to update the software online. So before, I had to actually disassemble the DRO and swap out these SD cards. But now that I can connect this to the internet, I can actually download new software and see it updated live. So I was running version 1.1.0, but I went in and saw that all these other releases were available, and I chose the latest 1.1.9. It downloaded it, it installed it, and it automatically rebooted the DRO. And now we can see in the upper right hand corner that I'm on version 1.1.9, which is a little different than the previous version. Stefano is constantly making changes to the setups. Now Software Update has its own button, and the servo menu is a little bit clearer. So there's a new way now to adjust some colors. So there's a lot going on. And I encourage you that if you're looking for like an out-of-the-box DRO, yeah, this might work for you because it is updatable. But I would suggest that this might be geared a little bit more toward the maker, somebody that's really interested in digging into the electronics a little bit, or at least the software. I'm having a blast, and I'm having a blast being able to contribute back to Stefano's project. One happy accident. I didn't really plan on this, but it just seemed to work out. This plug here that plugs the DRO into the rotary controller. Well, if I unplug the DRO display and plug in this special made cable, which attaches to this interface, that plugs into the side of my laptop. Instead of using the Dr. DRO display, which is a Raspberry Pi, I can actually use my computer as the display. I have Debian 12 installed on this laptop, and I'm using Visual Studio Code, which is again freely available. And I have the software downloaded from GitHub. Stefano has made it extremely easy for anybody to download the software, get it up and running, and it's just a matter of launching a debug session. And when I do, instead of using the display on the DRO, I'm now using the display on my laptop. So anytime I were to move the scales, let's say move the table and affect the scales, that's going to cause the display on my laptop to update. And conversely, if I am going to control the servo, I can do that from my laptop and will actually enable the servo and make it start turning, or I can index it or whatever. So this gives me an opportunity to do some debugging, maybe write some new code, and I can test it right here from my laptop using the actual equipment. Now, this kind of thing might be a little bit intimidating for some, but I suspect that a lot of my fellow hobby machinists are probably nerds just like me and geek out on stuff like this. So I'm having fun learning some Python. That's not a programming language that I have a lot of experience in, but it's actually pretty easy to understand. And with the advent of AI coding assistants, with things like GitHub Copilot, if you know what that is, it actually makes learning how to modify this code a lot easier. It can even tell me what something does, so I don't have to bug Stefano and ask him what he was doing when he wrote this. So what's next on the agenda for Dr. DRO and this whole servo motor setup? Well, this is what's next. This is my Brown and Sharp universal dividing head. I've used this in the past for some projects, and quite frankly, had I had the Dr. DRO and everything machined to actually make this work, it would have been a heck of a lot easier. I have to figure out just how I'm going to connect this servo motor up to this input shaft on the back of the dividing head. This mechanism, once I get it all figured out, is really going to make the use of a dividing plate completely unnecessary, because I can use the DRO to index when I am making gears. The other thing that I can do with this is use it to cut helical gears. When cutting a helical gear, it's not just at an angle you need to rotate the gear at the same time as cutting the teeth. When the dividing plate is not engaged, by spinning that input shaft, it's turning the chuck. And I do believe this is a 40-to-1 gear ratio. So I have to take that into consideration when I'm designing gear sets between the servo and the input shaft. I might have to do this with maybe 2 gears, maybe 3. I don't know yet. And I'm thinking I might be able to use these mounting holes that are on the back of the dividing head that would normally be used for a universal gear chain, that I might be able to use it to build a mount to mount the servo to it. But before I can even do that, I really need to take this dividing head apart. It is full of dried grease. It is very, very stiff, and that's going to be a project in and of itself. And I also want to figure out a different chuck for the front of it. I really don't like this one, and I don't think it's very concentric. So I need to come up with something that's a little bit better. Well, I think that's going to be it for this week. And I say this week loosely because this whole project took me about 3 weeks to actually put together. I spent 2 weeks trying to figure out that wiring and the programming. But I hope you liked it. I know I didn't do any machining, but we're going to get that back to doing something with machining, hopefully next week. I appreciate you watching, and if you're not a subscriber, please hit that subscribe button. It really helps. Thumbs up, comments are always welcome. Thanks for watching, and we'll see you on the next one.